Hello all. Today we'll solve the LC.73 set matrix 0. So here we'll be given an input matrix, and if an element is 0, we have to set its entire row and column to 0. Let's try to understand this visually first. So I have taken this matrix as an input, and here the center element is 0, right? So what I have to do in return is I have to update the row 1, like the second row, all the elements of the second row to 0, and since it is found in the second column, I have to update all the elements in the second column to 0. So this is what we have to do. Let's get into the solution part. So yeah, here I have taken this matrix as an example. Now let's start traversing each elements of the matrix. Okay, now the first element is 0, right? What we have to do is, now we know that this entire row has to be changed to 0 and this entire column has to be changed to 0. So I will not do the updation process now. Instead I will just note it down that this row has to be changed to 0, like the first row has to be changed to 0 and the first column has to be changed to 0. Now I will just move to the next element. Since this is not equal to 0, we can just ignore this. Now I will move to the next element. Now this is equal to 0. Now we know that this entire row has to be changed to 0. And from the 0 rows marker, we know that 1 is already going to be 0. But we have to update the 0 calls with 1 comma 3. What does this exactly mean? The first column and the third column is going to be set as 0. So that is what this actually means. Next we will continue our traversal process. Here 1 is not equal to 0, so we move to the next one, and this goes on, and there is no upcoming zeros, right? So next stage. Now we have found out that the first row element has to be changed to 0 and the first column and the third column element has to be updated with 0. Let's do that now. Yeah, after doing that process, we get this as a final matrix, right? So what I have done is I have updated the entire first row with 0 element, and I have updated the column 1 and column 3 as 0. So this is how we have to implement it. Let's get into the coding part. Let me, as discussed, let's do the traversal part first. Traversal, and we had the 0 rows and 0 column as a marker, right? Like to note down what row and what column has to be changed to 0. Let's define those variables. Right now I'm using arrays, like kind of a hash map here to note it down. 0 rows. Let's do the traversal part. Let me store the number of rows present in the input matrix in M and number of columns present in the input matrix in N. Let's just update it here too. Now here let's check whether the current element is equal to 0 or not. Matrix of I of j. If it is equal to 0, what we have to do is we have to update the 0 rows and 0 columns, right? So let's do it now. 0 rows of I is equal to true. So I'm just marking this particular row as true. Let's do the same for columns. Yes, I think now we have done with the traversal. Next we will start updating the rows and columns with zeros. Let's start with updating the rows part. If 0 rows of I is true, so if the row 1 is true, if the row 1 is marked as true, what I have to do is I have to change all the elements of that particular row to 0, right? Let's do that. Yeah. Now we have updated the rows. Let's do the same for columns. Here it is much simpler. We have to just change the m to n and 0 rows to 0 calls and n to m j I. We don't have to return anything. uh, yeah, that is how it is mentioned in the problem. Yes.